All right, everyone, get ready, because today we're diving into some really cool AI stuff.
Oh, yeah.
You guys sent in this article, and it's about a new technique called L-Mul,
Right.
and it claims it can totally cut down energy consumption in neural networks
Yeah.
by a lot, like 95%.
95%. Yeah, it's incredible.
95%. I mean, if that's even remotely true, we have got to unpack this.
Absolutely.
Especially because, and we all know this,
Yeah.
AI has a reputation for, well, being a bit of an energy hog, to say the least.
It is amazing how much attention this is getting. And,
Oh, for sure.
it makes sense.
Yeah.
We are seeing like this huge explosion in what AI can do.
Yeah.
But all that amazing stuff,
Yeah.
it doesn't come cheap.
Yeah.
The energy demands are enormous.
Totally. In fact, the article actually mentioned this crazy stat, and it said that running something,
Yeah.
like just running ChatGPT, can use as much power as 17,000, like average U.S. homes,
Wow.
every single day.
Every single day.
Yeah.
It's a lot of power.
So I gotta ask, why is AI such a power drain? Like, what's going on in there?
Yeah, it's not like there are, tiny robots running on treadmills inside the servers or anything.
Right, huh?
No, not quite. It really comes down to how many calculations are happening, like all the time, behind the scenes.
Okay.
Just imagine your brain, right?
Yeah.
But instead of, billions of neurons
Yeah.
firing off signals constantly, it's just happening in these AI models, but it's digital
Well,
and it's on a massive scale.
okay, so more activity, more energy. That makes sense.
Yeah.
But the article, it kind of hinted that it's not just about, like, the total amount of work these things are doing.
Yeah.
It's also about the types of work, right?
Exactly. Yeah.
It mentioned something about, like, this energy hog, this AI energy hog being fueled by something called floating point multiplication. I don't even know what that is.
Yeah. And this is where it gets really, really interesting.
Okay.
So think of it like this.
Okay.
Adding numbers together, that's pretty straightforward. Like stacking blocks, right?
Okay, I like that.
But then you start multiplying. And then on top of that, you start using decimals.
Right.
It gets a lot more complex, a lot more quickly.
Yeah.
It's more like building a pyramid now.
Right.
And so in computers, that extra complexity means they need more energy, they use more energy.
So all those little decimal points are really adding up.
They really do, yeah.
And the article, it said that floating point multiplication uses like 37 times more energy than just doing basic addition.
That's exactly right. 37 times, it's a huge difference.
Yeah, that's wild.
Huge.
So that's the problem, okay? So then L-Mul comes in, and it's like the potential superhero here, right?
Yeah, exactly. That's a good way to put it.
Okay, so how does it do it? How does L-Mul actually pull this off? Okay, so color me intrigued. How did L-Mul actually pull that off?
So L-Mul, what it does is it uses some really, really clever math tricks to kind of approximate, to get close to those really complex calculations.
Right. Without actually having to use all those decimals. Okay. Like instead of, imagine painstakingly building that whole pyramid block by block by block with all the decimals.
Yeah.
It's kind of saying, well, what if we could use like pre-made blocks?
Right.
I
like that. Yeah. So it's like it's finding a shortcut through a maze.
Exactly. Yeah.
Instead of having to go down every single dead end.
That's a great way to put it.
Yeah.
Yeah. The article highlights two big benefits to this. So first, it really cuts down on how complex these calculations actually are.
Right.
So going back to that, stacking blocks versus building a pyramid analogy.
Yeah.
With L-Mul, the complexity, it grows what we call linearly,
Right.
which means you're just adding one block at a time.
Right.
Versus with the pyramid, it gets really complex really fast. That's what we call quadratic growth.
Okay, so that makes sense. That's the speed boost.
Exactly.
But how does it actually save energy? Like, where does that come in? So this is where we get down to like the nuts and bolts of how computers work.
Oh,
at the lowest level, right?
Okay.
You see, computers, they don't think in decimals.
Right.
Like we do.
Yeah.
They use bits, which are these like tiny switches. You can think about it that way.
Okay.
And they can be either on or off,
Right.
a 1 or a 0.
Yeah.
And L-Mul is designed to work with those bits, but in a really, really smart way.
Okay.
It completely avoids those, energy-guzzling floating point operations.
So it's like it's speaking the computer's language, but in a way that's less exhausting for them?
Exactly. And here's the really exciting part.
Okay.
L-Mul, it's got the potential to be used for way more than just making large language models more efficient.
Wait, really? You're
Yeah.
saying this could be used for, like, any type of computation?
Potentially, yes.
Mm.
So think about it.
That's...
Scientific simulations
Yeah.
that require tons and tons of computing power,
Right.
or even like everyday apps on our phones. Almost anything that uses complex calculations, it could benefit from this.
Wow.
And the crazy thing is,
Yeah.
this isn't just theoretical.
Yeah.
Like companies, big companies, Google, NVIDIA,
Right.
they're already developing specialized hardware
Wow.
that can make L-Mul even faster and more efficient.
Wow. So they're really on board with this.
Yeah, they're starting to realize that energy efficiency, it's not like a bonus anymore.
Yeah.
It's like you need it to make it work.
Right. It makes sense with, climate change and all that.
Exactly.
But I do remember the article. It did mention some people are a little bit skeptical about all this, about L-Mul.
Right.
Something about integer operations being slower on the hardware we have now.
Yeah, you're right. There were some concerns, for sure. And they were valid concerns.
Okay.
So while integer operations by themselves
Right.
use less energy,
Right.
running them on hardware that's mostly made for, floating point calculations, that can actually slow things down. It's kind of like, imagine trying to read a book
Yeah.
in a language you don't really understand that well. You might know, like, each individual word,
Yeah.
but it's going to take you a lot longer to actually understand what's going on.
So it's a trade-off.
It is, yeah.
We get the energy savings, but then we might be sacrificing some speed.
Potentially, yeah.
Is there any way to kind of have both?
That's the million-dollar question, isn't it?
So how do we solve this speed bump? Is it just a matter of waiting for better hardware to come along, or is there something else going on?
It's probably a little of both, to be honest.
Okay.
The article, it talked about how special hardware,
Yeah.
like if we designed hardware specifically for L-Mul,
Okay.
that could be what really unlocks how good it could be.
Right.
It'd be like, imagine like a computer chip,
Yeah.
but it's like specially made, optimized for these, energy efficient calculations.
Right. So it's like if you had a dedicated lane on the highway.
Exactly.
For faster travel. Okay.
Yeah, exactly.
Okay. So I'm starting to see the bigger picture here.
Yeah.
It's not about just changing a little bit of the algorithm here and there. It's about rethinking
Fundamentally, yeah.
how we design computer systems from the ground up.
Exactly. And that's what's so cool about this. You know, it's like, it reminds me of the early days of any big technological change.
Sure.
Think about when we went from those giant desktop computers to sleek smartphones, It wasn't just about making things smaller. It was about changing, totally changing how we use technology.
So are you saying that L-Mul could start a similar revolution?
It could, yeah.
Where energy efficiency is just the core of how we design things.
That's the hope, yeah.
Yeah.
Imagine,
Yeah.
imagine a future
Yeah.
where all this AI power, everyone can use it.
Right.
Not just the people with these giant data centers and, huge energy bills.
Right.
We could have AI running on our phones, our cars, even those little sensors.
Right.
And they'd be using way less energy.
Wow. Yeah, that's a future I can definitely get behind.
All right.
This deep dive has been really eye-opening for me,
Yeah.
It's made me realize how much energy we're using for all this AI stuff.
Easy to forget, right?
And who knows, maybe thanks to things like L-Mul,
Yeah.
we'll get to a point where it's not this hidden cost anymore.
Yeah, absolutely. And, it's funny because sometimes the best way to get better, to be more efficient,
Yeah.
isn't by adding more power or making things more complex,
Right.
It's about finding a really elegant and simple solution.
Well said. And on that note, that is all the time we have for this deep dive, but we want to leave you with one last thought to chew on. What other technologies could use this kind of energy-aware approach? What if every single piece of code, every algorithm, everything we do in the digital world was designed with efficiency in mind? It's something to think about as we enter this exciting new age of computing. Until next time, keep those brains buzzing, but maybe try to do it with a little less wattage.